Okay, in this video we're going to be looking at two variances or standard deviations. Now we're still on inferences with two samples here. We've already talked about two proportions. Also we talked about two independent means, and also we looked at dependent samples where we were dealing with matched pairs. Now we're going to be looking at two variances or standard deviations as we talk about inferences with two samples. So what we're going to introduce in this section is what they call the F test. And that's going to be used in testing claims made about two population variances or two population standard deviations. So here the F test, which is named after a statistician named Sir Ronald Fisher, and that's going to be the test that we will use in this particular video. Now the F test requires both population variances to have normal distributions. Now this test is very sensitive to departures from normal distributions, so the normality requirement is very strict. Okay. Now the first thing I'm going to do here is give you some notation that's going to be used in this particular video. So here we'll start with notation. Okay. Now first of all, S1 square, that's going to be the larger of the two sample variances. Okay, because you'll be given two sets of data. You'll have each set will have a sample size, each set will have a variance, and sometimes you may have your sample mean given to you, which in this case you won't need. But you'll pick the larger of the two standard deviations. That will represent the larger of your two variances here. So S1 squared will be the larger of your two sample variances. Now, again, sometimes the standard deviation might be given, so the variance you'll have to take the standard deviation and square it. You'll see that in some of these examples that I'll do here. N1 is the sample size with the larger variance. N1 will be the sample size of the larger variance. And then sigma 1 square, that's going to be the population variance where the sample with the larger variance was drawn. Okay. Okay, so that's the notation there for the first set. S1 squared will be the larger of the two sample variances. N1 will be the sample size that has the larger variance, and sigma 1 squared will be the population variance where the sample with that larger variance was drawn. And then you have your S1, S2 square, and N2, and sigma 2 square. Those are used for the other sample and population. Okay, so that's the notation that we'll be using in this particular video. Now, there are three requirements for doing the hypothesis test for two variances or two standard deviations. And by the way, in the last few videos that we did for Chapter 9, we've had to do a hypothesis test and also a confidence interval estimate. Here in this video, we're only going to be concentrating on the hypothesis testing for two variances or two standard deviations. So the first requirement is this: the two populations are independent. And what that means is this: that one population has no relationship with the other population. Or we can say that the sample from the first population has no relationship with the sample of the second population. So here those two populations have to be independent. Then number two, the two samples are simple random samples. In other words, by definition of a simple random sample, the samples of the same size has the same chance of being selected. Okay? Samples of the same size has an equal chance of being selected. And then number three, each of the two populations and I'm going to capitalize this word, they must be normally distributed. And that's regardless of their sample sizes. This F test, this one has a very strict requirement. And that's very important. Number three, because you must have normally distributed populations regardless of their sample size. Okay, so it's a strict requirement for the F test. Now, once those three requirements have been met, that's when we can conduct conduct a hypothesis test with two variances. But in this case here, we're going to need a test statistic for that. So here, I'll give you the test statistic for your hypothesis test, which is all that we'll do in this video with two variances. Okay, and that test statistic is your capital F. And that's equal to S1 squared divided by S2 squared. Now here in this case here, your S1 squared, that's going to be the larger of the two sample variances. Now sometimes you may be given a sample standard deviation. Okay, but in this case, you'll take the larger of your sample standard deviation, let that be S1, and then you'll take that S1 and then square it. Okay, and then S2 squared will be the smaller of your two sample variances. And again, the smaller of your two sample standard deviation will be S2. So in this case here, you'll take that S2 and square it. Okay, now the p-value, to calculate the p-value, we'll just use technology. And in this video, I'm going to be using the TI-83 or the 84 Plus calculator. So here the technology would be the easiest way to calculate your p-value. Okay. Alright, now let me go into more detail of what the F distribution is, because that's what we're using for this hypothesis testing. We're using the F test, so let's talk about the F distribution and its properties. There are three properties of the F distribution. Number one is this. The F distribution is not symmetric. Now with the normal distribution, it is symmetric because it's like a bell-shaped curve. The left side has the mirror image of the right side. In this case, it does not, and I can show you an illustration of that F distribution. So here you can see what the F distribution curve looks like. It's usually skewed to the right, as you can see. And then number two, the second property is this. The values of the F distribution cannot be negative. So you have the values of the F distribution, it cannot be negative. Okay. So again, pulling up that figure of the F distribution curve, you see that it starts at 0. Usually with the normal distribution, you have negative and positive values there on the left and the right side. But in this case, since it's positively skewed, your values here start at 0 and go on up. It's never negative. And then the third property is where the exact shape of the F distribution depends on the two different degrees of freedom. Okay, because you're given two different data sets or sample statistics. N1 is the sample size of the one that has the larger of the two sample variances. N2 is the sample size that has the smaller sample variance. So here you have two different degrees of freedom. N1 minus 1 and N2 minus 1. And that shape can depend upon those two different degrees of freedom. Okay. Alright, now let's look at some examples of the F test and how to conduct a hypothesis testing using the F test with two variances or two standard deviations. Alright, now let's take a look at example E1. And it says here, words were displayed on a computer screen with background colors of red and blue. Results from scores on a test of word recall are given below. Use a 0.5 significance level to test the claim that the samples are from populations with the same standard deviation. Assume that both samples are independent, simple random samples from populations having normal distributions. Does the background color appear to have an effect on the variation of word recall scores? So here we got the red background where the N, your sample size is 35, the sample mean is 15.71, the sample standard deviation is 5.94. For the blue background, sample size of computers with blue backgrounds is 37. The sample mean is 12.99. The sample standard deviation is 5.92. Now, since we're given the sample standard deviation, we have to pick the larger of the two and let that be S1. The larger of these two sample standard deviations is 5.94. So we're going to let S1 be 5.94. And S2 will be 5.42. Well, if S1 is going to be 5.94, so the population standard deviation, or the population variance, which is sigma 1 squared, that's going to be the variance of the population with the sample that has the larger variance being drawn from. That's going to be represented by the red background. And then the blue background will be the sigma 2 square. That's going to be the population variance of the second one that has the smaller standard deviation. So sigma 1 squared will be the red background, sigma 2 squared will be the blue background. Okay, now let's start the hypothesis testing. In step number 1, you want to write your original claim in symbolic form. And in this case, our claim is that the samples are from populations with the same standard deviation. That means that this has to be equal to this. Okay? So that means sigma 1 squared is equal to sigma 2 squared. So if it's the same standard deviation, that means it has to have the same variance. So that's why sigma 1 squared is equal to sigma 2 squared. That's your original claim. Now step number 2 is the opposite of that original claim. Well, the opposite of equal to, of course, is not equal to. So sigma 1 squared is not equal to sigma 2 squared. And then step number 3 is writing the null and the alternative hypothesis using steps 1 and 2. So in this case here, the alternative is the one that has the not equal to. So it'll be sigma 1 squared not equal to sigma 2 squared. And then your null is the one that has the equal sign in it. So sigma 1 squared equals sigma 2 squared. Okay. Now again, if you're not familiar with that 8-step hypothesis testing procedure, you might want to refer to the video for section 8-2 that talks about the basics of hypothesis testing. And that's where I introduced that 8-step procedure for hypothesis testing. Alright, step number 4 is the level of significance. Now we're using a 0.05 significance level. So alpha is equal to 0.05. Step number 5 is calculating the test statistic. Well, here our test statistic is this. F is equal to S1 squared divided by S2 squared. Okay? S1 squared is the sample variance of the, or the larger of the two sample variances. Here we're given standard deviations here. We're taking the larger of the sample standard deviation, which is of the two sample standard deviations here. That's 5.94. That's going to be S1. But to find the sample variance, you have to square it. So here, S1 is 5.94, and that's going to be squared. Divided by S2 squared, that's 5.42. And that has to be squared. Just keep in mind you're given, in this case, sample standard deviations here. So you have to square each one of those to find the variance. Now this we can type in the calculator. This is just a simple division problem here. So if I do 5.94 and hit the x squared button to square it, then divide that by 5.42, and then hit the x squared button to square that, and then hit enter, I get 1.201086587. But if I round that off to 2 decimal places, that would be 1.20. 1.20. So your test statistic, or your F test statistic, will be 1.20. Alright, step number 6 is finding the p-value. Now we're going to use our graphing calculator to do this one. Okay? Now I'm going to show you how to do this. We're going to press the button that says Stat, and we're going to use our right arrow key to go to Test. Now we're going to hit our down arrow key because the menu item that we're going to be using is going to be 2SAMP F Test. That's this menu option right here, 2SAMP F Test. And then go ahead and press enter. Now we're dealing with just the sample data. So here, no, we're not dealing with data, we're dealing with statistics, sample statistics here. So we want to highlight the stats button, right? The stats option right here. So I'm going to put the blinking cursor over stats and then press enter. Now if we were given raw data, we have to be given data values here where we have to calculate the mean and the standard deviation as well. But here we're given S1 and S2 and the sample size. So we want stats to be highlighted. Then hit your down arrow key. SX1. Now, I'll let S1 be 5.94. That's the standard deviation of the first data set, or the first sample statistics. So I'm going to type in 5.94. Now it really doesn't, the graphing calculator doesn't matter. For the graphing calculator, it doesn't matter which one you use. Whether the 5.94 or the 5.92. Because what it does, it will calculate the correct F value for you and the correct P value for you. Okay? So here either sample can be designated as S1. But here I'm going to be consistent and use 5.94 as the sample standard deviation of the first one. And then its sample size. Now keep in mind, if 5.94 is being used here for the first standard deviation, then N1 will have to be 35. So I type in 35. And then my other standard deviation was 5.42. And then N2 was 37. Now for sigma 1, I have 3 options to choose. And I have to look at my alternative hypothesis to determine which one I'm going to have to use. So in this case here, H1, that's my alternative hypothesis, has not equal to. So I need to select the one that has not equal to. So I put the blinking cursor above not equal to sigma 2 and then press enter to highlight it. And then I'm going to go down to calculate, highlight that, and then hit enter. Now notice I did get the same F value, which is my test statistic here, which is 1.20, rounded to 2 decimal places. Here's my p-value right here, 0.58834047774. Rounded to 3 decimal places, that would be 0.588. And I also need to mention right here, it picked the 5.94 as the larger of the 2 standard deviations, and it became S1. That's your standard deviation of that's the larger of the 2 standard deviations here. Okay, so now that p-value is 0.588. Okay. So step 6 is calculating the p-value. Step 7 is the decision rule, where if the p-value is less than or equal to alpha, you're going to reject the null hypothesis. Okay. Now my p-value was 0.588. The alpha level there was 0.05. Now as you can see here, 0.588 is greater than 0.05. Here, this decision rule is not satisfied, so that means we fail to reject the null hypothesis. And when we fail to reject the null hypothesis here, we're going to have to write our conclusion statement using simple non-technical terms here. Alright, in this case here, that claim, as I should have mentioned here, was the null hypothesis here, because the original claim was the populations have the same standard deviation or the same variance here. The claim is your null hypothesis. We fail to reject the null hypothesis. Okay? So that means that there is not sufficient evidence to reject the claim that the samples are from populations with the same standard deviation. Alright. Now the other part of that question is, does the background color appear to have an effect on the variation of word recall scores? And the answer to that would be no, because of the fact that we don't have any sufficient evidence where the samples are from populations with the same standard deviation. That means that the word recall scores appear to be the same when the color is changed. Alright, now let's look at another example. Alright, this one says, the accompanying table gives results from a study of words spoken in a day by men and women. Assume that both samples are independent simple random samples from populations having normal distributions. Use a 0.05 significance level to test the claim that the number of words spoken in a day by men vary more than the number of words spoken in a day by women. Okay, so now we have our men. The sample size is 187. Sample mean is 15,667.2. Sample standard deviation is 8,632.5. And then for women, the sample size is 209, and that sample mean is 16,215.6, and the sample standard deviation of 7,301.7. Now, the larger of the two sample standard deviations is this one. So that means when I'm dealing with the population standard deviation, sigma 1 squared, or the population variance, would be for men. Sigma 2 squared would be the population of women. Okay. Alright, and I'm letting S1 be the 8632.5 and S2 be 7301.7. The S1 is going to be the larger of the two standard deviations here. And then N1 will be the sample size that contains the larger of the two standard deviations. That's 187. N2 is 209. Okay, so we'll start our hypothesis testing procedure. In step number 1, we want the original claim. And in this case here, the number of words spoken in a day by men vary more than the number of words spoken in a day by women. So here's sigma 1 squared. That's going to be the sample variance of the number of words spoken in a day by men is greater than sigma 2 squared. That's the population variance of the number of words spoken in a day by women. Step number 2 is the opposite of the original claim. And in this case here, the opposite of greater than will be less than or equal to. So sigma 1 squared is less than or equal to sigma 2 squared. And then step number 3 is writing the null and the alternative hypothesis. So one of these will represent the alternative hypothesis because the alternative has either greater than or less than or not equal to. In this case, it's this original claim, where sigma 1 squared is greater than sigma 2 squared. And I'll write the word claim. And then your null hypothesis always has the equal sign in it. Sigma 1 squared equals sigma 2 squared. Alright. Step number 4. Is the level of significance here. You're asked to use a 0.05 significance level, so let's write that down. Alpha is equal to 0.05. And then step number 5 is calculating the test statistic using that F is equal to S1 squared divided by S2 squared. Now we're only given the sample standard deviation, so that means for the sample variance we have to square it. Our S1 in this case is 8,632.5. So here the numerator will be the 8632.5, and that's squared. That's divided by S2, that's 7,301.7, and that's squared. Okay, so I type in 8,632.5 and then x squared divided by 7,301.7, and then x squared just squared. Then hit enter. And we get 1.397736168. To 2 decimal places, I will say 1.40. So the test statistic here is 1.40. Now step number 6 is calculating the p-value. And we're going to use the graphing calculator to do just that. Okay, I'm going to pull this down so that way you'll see what I'm doing here. Here we're going to press the stat key and then use the right arrow key for your test. Press your down arrow key to find your 2-samp F test. 2-samp F test. Press enter. Now we're dealing with sample statistics here, so we want stats to be highlighted. Okay. Then press your down arrow key. we're letting the sample standard deviation of the first one be 8632.5. So we type that in, press enter. From that sample standard deviation of 8632.5, the first sample size is 187. And then the second sample standard deviation is 7,301.7. And then its second sample size is 209. Now let's look at our alternative hypothesis to see which one of these we're going to have to select. Notice in the alternative hypothesis we have greater than. So we want to select the one that says greater than sigma 2. So we put the blinking cursor over greater than sigma 2 and then press enter to highlight it. Then press the down arrow key to highlight calculate and then press enter. Now we did get the exact same F test statistic of 1.39, 77.36168. Rounded, it will be 1.40. Here's your p-value underneath it, 0.0094422593. To 3 decimal places, we will say 0.009. Okay. So the p-value there is 0.09. Now step number 7 is the decision rule. And that's if the p-value is less than or equal to alpha, you want to reject the null. Otherwise, we fail to reject that null hypothesis. Now the p-value there was 0.009. The alpha level of significance from step 4, is 0.05. So here 0.009 is less than 0.05. So here we reject the null hypothesis because this does satisfy the decision rule. And then step number 8 is writing the conclusion statement using simple non-technical terms. Here the claim was the alternative hypothesis and we rejected this null. So here we can say that there is sufficient evidence to support the claim. So here there is sufficient evidence to support the claim. That the number of words spoken in a day by men vary more than the number of words spoken in a day by women. Okay. Alright. So that's how you do that 8-step procedure with this one here. Because this one had like the fact that words spoken in a day by men vary more than. And I want to show you an example of just that. Okay, I will do one more of these. And I will conclude this video. Researchers conducted an experiment to test the effects of alcohol. The errors were recorded in a test of visual and motor skills for a treatment group of 23 people who drank ethanol and another group of 22 people given a placebo. The errors for the treatment group have a standard deviation of 1.93, and the errors for the placebo group have a standard deviation of 1.21. Use a 0.05 significance level to test the claim that the treatment group has errors that vary more than the errors of the placebo group. Assume that both samples are independent, simple random samples from populations having normal distributions. Okay, now what I want to do here is create a table of this. Okay, because one for treatment, and the other one is placebo. We're only given the sample size and then your sample standard deviation for each one. Now for the treatment group, there are 23 people, so your N is 23. And then another group of 22 were given a placebo, so your N for the placebo group is 22. Now the errors for the treatment group have a standard deviation of 1.93. So this will be 1.93 for the treatment group, and the errors for the placebo group have a standard deviation of 1.21. Okay, so that's much better to have it this way in the form of a table than it is to read it like this in what they call paragraph form. Okay, now the larger of the two standard deviations is this one right here. That's for the treatment group. So here, sigma 1 squared will represent the treatment group. Sigma 2 squared will be the placebo group. And in that, N1 will have to be the treatment group because that's going to come from the, that's going to be the sample size from which the larger of your two sample variances or the larger of your two sample standard deviations is drawn from or taken from. So N1 will be 23. That would mean N2 will have to be 22. And of course S1, that's the larger of your two standard deviations, that's 1.93. S2 will be the smaller of the two, 1.21. Okay. And then we can conduct our hypothesis testing procedure for this. Step 1 is the original claim. And that's where we're testing the claim that the treatment group has errors that vary more than the errors of the placebo group. So we want the first population variance to be bigger than the second population variance. So sigma 1 squared is greater than sigma 2 squared. Now step number 2 is the opposite of the original claim. Now the opposite of greater than will have to be less than or equal to. So sigma 1 squared would be less than or equal to sigma 2 squared. And then step number 3 is writing the null and the alternative hypothesis. The one that doesn't have the equality in it is this one right here. That's your alternative hypothesis. So here sigma 1 squared is greater than sigma 2 squared. That's the claim. And the null will be your sigma 1 squared equal sigma 2 squared. And now step number 4 is the level of significance. So here your alpha level. You were told to use a 0.05 significance level, so your alpha level will be 0.05. And then step number 5 is calculating the test statistic. So here we're going to be using the F is equal to S1 squared divided by S2 squared. Now here S1 is 1.93, so that would be 1.93 squared. We're using the larger of the two standard deviations here. And then the smaller of the two standard deviations will be your denominator. And it'll be 1.21 squared. And using the graphing calculator, if I do 1.93 squared divided by 1.21 squared, you'll get 2.54415,682, but to two decimal places, it'll be 2.54. So your test statistic here is 2.54. Now step number 6 is calculating the p-value. And we're going to use our graphing calculator for this one as well. So if we press the stat key, right arrow to test, push the down arrow key to find 2SIMP F test, which is this menu item here, and then press enter. Stat should be highlighted as usual because we're only given sample statistics here. Your S1, that's this number right here, S1 was 1.93, so we type that in. N1 is the sample size where the larger sample standard deviation is drawn from. That's 23. S2 is 1.21. And then N2 was 22. And if you look at your alternative hypothesis, greater than is what we have. So we should highlight greater than greater than sigma 2. Right arrow key and then press enter to highlight greater than sigma 2. Hit your down arrow key to calculate and press enter. That's your F statistic right there. This is your p-value. To 3 decimal places, that will be 0.018. Okay. Now step number 7 is the decision rule. If your p-value is less than or equal to alpha, reject the null hypothesis. Okay, now the p-value in this case was 0.018. Your alpha level was 0.05. Compare these two, 0.018 is less than 0.05. And that does satisfy the decision rule, so we reject the null hypothesis. And then finally, step number 8 is writing our conclusion statement here using simple non-technical terms. The claim was the alternative hypothesis, and we rejected the null. So that means that there is sufficient evidence to support the claim. So we've got there is sufficient evidence to support the claim. That the treatment group has errors that vary more than the errors of the placebo group. Okay. Okay. So that would conclude this particular video on doing a hypothesis test with 2 variances or 2 standard deviations.